wabarakatuh. My name is Muhammad Amir Izzat bin Majidi. My matrix number is 01DKA21F1114. Today I want to discuss about introduction. First, definition of slope. Number 2, type of slope feature. Number 3, factor cause a slope feature. Number 4, method to prevention and conservation of slope. Definition of slope. A slope is an inclined ground surface which can be either natural or human-made. Slope stability refers to the condition that an inclined slope can withstand its own weight and external force without experiencing displacement. Slope stability uses principle of soil or rock mechanics, geotechnical engineering, and engineering geology. Case study that involve the behavior of slope have led to an improved understanding of slope stability mechanics. The development of complex constitutive model, the recognition of laboratory and in situ testing, limitation and the evolution of new instrumentation technique to assess the slope response. Next, type of slope feature. Number 1, translational feature. Number 2, rotational feature. Number 3, wedge feature. And the last one, compound feature. And then I give to Muhammad Alif to next presentation.
Thank you, Amir Izzat. My name is Muhammad Alif and my matrix number is 01DKA21F1139. I will talk about factor causes a slope failure. First is erosion. Water and wind continuously erode natural and man-made slopes. Erosion changes the geometry of the slope, ultimately resulting in slope failure or more apply a landslide. Rivers and streams continuously scour their banks, undermining their natural or man-made slopes. Next is rainfall. Long periods of rainfall saturate, soften, and erode soils. Water enters existing cracks and may weaken underlying soil layers, leading to slope failure, for example, mudslides. Thirdly is earthquakes. Earthquakes induce dynamic forces, especially dynamic shear forces that reduce the shear strength and stiffness of the soil. Structures founded on these soils would collapse, structures buried within them would rise. The quickness with which the dynamic forces are induced prevents even coarse-grained soils from draining the excess pore water pressure. Thus, slope failure in a seismic event often occurs under undrained condition. After that is external loading. Loads placed on the crest of a slope add to the gravitational load and may cause slope failure. A load placed at the toe, called a berm, will increase the stability of the slope. Berms are often used to remediate problem slopes. Lastly is rapid dry down. Reservoirs can be subjected to rapid dry down. In this case, the lateral force provided by the water is removed, and the excess pore water pressure does not have enough time to dissipate. The net effect is that the slope can fail under undrained condition. If the water level in the reservoirs remains at low levels and failure did not occur under the undrained condition, seepage of groundwater would occur, and the additional seepage forces could provoke failure. Next, I will talk about methods to preservation and conservation slope. First is flattening the slope. Second, eliminating part of the soil or rock. Third is eliminating load from the top of the slope and therefore reducing the shear stresses on critical planes. After that is constructing pressure berms at the toe of the slope and thereby providing extra safety against toppling failure. Fifth is replacement of slip material by free draining materials and therefore reducing the build-up of poor water pressure. Lastly is biorecompaction of slip debris to provide more resistance against loading.
Assalamualaikum, especially to my lecturer. My name is Muhammad Kushairi bin Asri. My metric number is 10DKA21F1133. Today, I will explain about laboratory data analysis, which is soil density test and triaxial test. Soil density test. What you know about soil density test? Soil density test can be defined as a test that studies the dry density of soil or pavement material that has been compaction, and then it is measured to determine whether or not compaction can be achieved in a construction. This density test sample is taken in the construction area to determine or evaluate the density of the soil that has been compacted. This test is performed at the construction site after the compaction or filling of the soil has been done. Soil density is needed to determine soil bearing capacity by analyzing soil stability, pressure on the foundation surface, and soil structure design. This soil density test is very necessary in cases such as building construction, basement or road construction, and so on. Ini ialah jadual soil density test data collection bagi sampel tanah yang tidak terganggu yang kami perolehi di tapak, di mana kami hanya mendapatkan satu sampel sahaja. Length of soil sample ialah 8.2 cm dan diameternya ialah 3.8 cm. Mass of soil sample ialah 188.92 gram dan density of soil ialah 2.03 gram per cm kuasa 3. Average density of soil ialah 2.03 gram per cm kuasa 3. Triaxial test. The triaxial shear test is the most versatile of all of the methods for testing the shear strength of soil and finding its cohesion C and angle internal friction theta. It can measure the total as well as the effective stress parameter and can be conducted on any type of soil. Drainage condition can be controlled and pore water pressure and volume changes can be measured accurately. The failure plan is not forced in this test, and the stress distribution of the failure plan is fairly uniform. Specimen can fail on any width plan or can simply bulge. The triaxial test, which determines the shear strength and stiffness of soil and rock, is one of the most versatile and widely performed geotechnical laboratory tests that is used in geotechnical design. Ini adalah jadual data collection for triaxial test yang kami perolehi di tapak, di mana kami mendapatkan 3 sampel, iaitu sampel A, sampel B dan sampel C, di mana nilai bagi sampel A ialah minus stress 20 kN per m², deviated stress ialah 150 kN per m², major stress 170 kN per m². Nilai bagi sampel B pula ialah minus stress 80 kN per m², deviated stress 160 kN per m², major stress 240 kN per m². Nilai bagi sampel C pula ialah minus stress 245 kN per m², deviated stress 195 kN per m², major stress 440 kN per m². Melalui data ini, kita akan membuat satu graf triaxial test bagi mencari nilai cohesion of soil C dan friction angle of soil theta. Titik pertama di sebelah kiri, kita akan menggunakan nilai minor stress, manakala titik kedua di sebelah kanan, kita akan menggunakan nilai major stress. Begitu juga dengan lengkungan sampel kedua, iaitu titik pertama di sebelah kiri, kita akan menggunakan nilai minor stress dan titik kedua di sebelah kanan, kita akan menggunakan nilai major stress. Dan sehinggalah selesai bagi kesemua sampel lengkungan yang terdapat dalam jadual. Langkah 1. Lukis paksi X mewakili normal stress dan paksi Y mewakili shear stress. Gunakan skala yang sama untuk normal stress dan shear stress. Contohnya, skala 2 cm sama dengan 50 kN/m². Langkah kedua, ambil nilai minor stress bagi sampel A iaitu 20 kN/m², kemudian buat satu titik kecil pada paksi normal stress. Kemudian ambil pula nilai major stress sampel A iaitu 170 kN/m², kemudian buat titik kecil pada paksi normal stress. Langkah ketiga, menggunakan pembaris, ukur jarak antara titik minor stress dan major stress bagi sampel A, tujuan untuk mencari titik tengah. Langkah keempat, letakkan hujung jangka lukis yang tajam pada titik tengah dan bahagian pensel pada mana-mana titik minor stress atau major stress. Pilih salah satu, kemudian buat lengkungan 180 darjah. Langkah kelima, ulangi langkah 1 hingga 4 untuk sampel seterusnya sehingga selesai bagi ketiga-tiga sampel iaitu A, B dan C. Langkah keenam, buat satu garis lurus bermula dari atas lengkungan yang paling tinggi sehingga lengkungan yang paling rendah iaitu lengkungan sampel A. Langkah ketujuh, ambil bacaan pada garis lurus yang bersilang dengan paksi shear stress. Ia merupakan nilai cohesion of soil C. Langkah ke-8, buat satu garis pendek berbentuk horizontal yang bermula dari hujung garis lurus yang menyentuh paksi shear stress. Langkah ke-9, ambil jangka sudut dan ukur sudut kecondongan garis lurus yang panjang itu tadi. Ia merupakan nilai friction angle of soil theta. Setelah selesai semuanya, kami memperoleh nilai bagi cohesion of soil C sama dengan 69.8 kN/m², manakala friction angle of soil ialah 5 darjah. Itu sahaja daripada saya dan saya serahkan kepada ahli kumpulan saya yang seterusnya. Sekian, terima kasih.
Assalamualaikum warahmatullahi wabarakatuh. My name is Umar Khan bin Haidil and my reference number is 01DK21F1138. So today I'm going to talk about the calculation for the stability of slope. This is our question for today. So on the previous presenter, my friend already got the answer for the threshold test, which is at this time we can find the stability of slope calculation. So the formula to check the stability of slope is we use the F equal to CR area theta divided by WD, and we get 2.07. In this case, we can use this number because 2.07 is bigger than 1.5, so it is clearly safe. So this is our graph that we use to find the stability of slope. That's all from me. Thank you.